So we will see some recap of the previous lecture. In previous lecture, I think we have started uh, third chapter, that is thermodynamics. Am I right?
Yes, sir.
Yes, sir.
Okay, and in that we have studied or we have discussed related to energy. So energy neither be created nor be destroyed. It can be converted. Thermodynamics notes upload kara. Okay, I will do it. So energy neither be created nor be destroyed, but it can be changed from one form to the other form. Yes, and to change some things, the energy is responsible. Okay, for any changes, energy is responsible. Okay, that we have studied. This one is the syllabus, and that ability to change, to make some changes. It means to run vehicle, it needs to change energy from chemical energy, that is petrol, diesel, to mechanical energy. Okay, and that mechanical energy runs the vehicle. Okay, so one more definition you have told, what is that? Capacity to do work, like that. Am I correct?
Yes, sir.
Yeah, capacity to do work. So you can say to do some work, it required some energy. Okay, always without energy, without then there should not be a work. Okay, so we are proceeding in that respect. So heat and work, these are very important phenomena, and many times students are more confused in that. So what is mean by heat? Mostly the students are mainly confused, or they are considering heat and temperature both are same. Am I right? तुम्हाला पण असं वाटतंय का? See, when we are learning in offline mode or before that, so students, when I ask what is the difference between heat and temperature, the students, many of the students tell that the heat and temperature both are same. Okay, so what is your opinion? At first, I have
Different.
told, yeah, Sally told that the heat and temperature both are the different. Okay, so we will see in next whether they are different, whether they are same. Now we have seen there are two types of the energies. First one is the internal energy. The internal energy is due to the molecular motion, arrangement of atomic structure, and its chemical composition. Okay, so this is the internal energy. Now we are going to see now external energy. Which are those external energies? That potential energy and kinetic energy. That external energies are mainly related to work. Do you get it? The external energies are mainly related to work. Okay, most of the times. Work, what is mean by work? If suppose this is the block, simple diagram that you have I think learned before that also, but ground is not straight, so I have to draw ground straight. Okay, on that if I put some block. Okay, so when I apply force here, when I apply force here, that is F. Here we have mass M. So what will happen when
Block
I,
this
The box
block
will be
this
displaced in the direction of the force.
yeah, block will be displaced in the direction of force. That means work is done. Okay, due to that force is due to some energy. Okay, there may be a manual energy, there may be some mechanical energy, there may be some steam energy or some other energies source. So with that, if we apply force, okay, force is the result of that energy, or we can say form of that energy. Okay, so the block will move in this direction, it means work happen. So this external energy, that is potential energy and kinetic energy, are mainly related to work. Okay, then various applications of the thermodynamics. So the thermodynamics is very large area. Thermodynamics covered very large area. So this is some examples that internal combustion engines, steam and gas turbines, jet propulsion, nuclear power plants, etc. Power absorbing devices like compressors, pumps, refrigeration, and air conditioning plant. Okay, so these are the, not only these are the examples. Okay, if you are boiling water, this is also comes under the thermodynamics. If you are going to boil tea, you are making tea, then it also comes under the thermodynamics. So thermodynamics is related to our day-to-day life. These are the examples or the applications of thermodynamics. Okay, but we can observe this all changes in our day-to-day life also. Okay, so these are the some images for that applications. So here, this is solar power plant, hot water tank, then this is the refrigeration, our fridge, this one is the aeroplane, these are the industrial area or the nuclear power plant. Then here again, this is also a compressor and all these things, it is again nuclear power plant or boilers are used. This is industry. Now, microscopic versus macroscopic. There are two types of studies. One is the microscopic and another one is the macroscopic. Now, actually, in previous lecture, I have explained that related to temperature. Okay. Instead of reading that slide, I will explain related to temperature. Okay. Once again, if suppose this pot filled with water, or this water is at normal temperature, it means the molecules having some vibration. Okay, so if I consider one molecule here, I focus only on single molecule from the water, and if I start to heat from normal water, if it is normal water, and if I start to heat, okay, and if I write readings, that is mean readings related to behavior of that molecule. Okay, तुम्हाला दिसतंय ना हे?
Yes, sir.
Yes.
Okay. Listen carefully, then give your opinions. At first, पहिल्या सुरुवातीलाच मी सांगितलेलं आहे, कोण चुकीचं आहे कोण बरोबर आहे याच्यापेक्षा डिस्कशन इज व्हेरी इम्पॉर्टंट. Like this is very interesting subject, so you are also aware with that. So here we have one molecule. When I increase temperature or if I add heat, this is the heat energy I am going to add. Due to that energy, when I adding energy, it means addition of energy. Am I correct?
Yes, sir.
Yes, sir.
And due to that, the if I add energy, due to that energy, molecule's behavior will change. Okay, so these molecules start vibrating much more. So if I record this all, it means suppose at 10 degrees Celsius how it behaves. Okay, at 50 degrees Celsius how these molecules behave, irrespective of all other molecules or all resultant of that all molecules. So this study comes under the microscopic view or approach. Do you get it?
Yes, sir.
Okay, we are not going to check or observe or notice the behavior of other molecules. We consider only one molecule, or we can say atom. Now macroscopy. Now macroscopy. In same, if I add thermometer, I will choose another color so you will get easily. So suppose this is thermometer. If I add here, so it will show some temperature, correct? If I add energy, thermometers is the device which can measure only. It will not increase the temperature, it will not reduce the temperature. Okay, the purpose is only to measure. We can measure with the sense also, but it is not countable. It is not countable. If you put your hand into that pot, and can you tell that it is 75 degrees Celsius? Okay,
No,
when you put your hand inside that, it is 35 degrees Celsius. Take for what we can say, for bath. It is possible?
no, sir.
No, sir.
No.
No.
So these things will be
No, sir.
yeah. So for that we required some measuring instruments, and the measuring instruments are to measure only. They are not adding any type of energy, or they are not removing any type of energy. Okay. So if suppose after 5 minutes or 10 minutes this thermometer shows temperature here about 30 degree. Okay, if I put this thermometer near to that molecule also, so whether that 30 degree Celsius temperature is of that single molecule, or that 30 degree Celsius is the average of all molecules,
Average of all molecules.
average of all the molecules. It means whatever going on at the molecular level, we are not worried about that. Okay, we want average, okay, average behavior or average changes in the substance. So such type of study is called as macroscopic study. Such study is called as macroscopic study. Do you get it?
Yes, sir.
Is anyone having any doubt? See, if you are clear with the concept, then you can think on that. If you don't know what is the microscopic, what is the macroscopic, then you can't think on that. So for thinking purpose, you should know some things related to that matter. Okay, this is in thermodynamics. Now in fluid also, okay, in fluids also, if suppose the fluid is one second, suppose this is the pipeline, okay, and fluid, that is water, suppose flowing in this direction. If suppose, if suppose this one is molecule I take for consideration, and when it flows from this first point to second point of that pipeline. And if I observe behavior of that molecule, it means here what he behaves, okay, whether the flow that molecules moving in straight direction, whether it is rotating about itself or center of its own, okay, that is laminar flow, turbulence flow, all these things are going on. So if I study and record that behavior of molecule up to that point, if it is a flowing fluid, okay, it is moving in this direction. Do you get what I am talking?
Yes, sir.
Yes, sir.
So now tell me, this study comes under uh, which approach, whether it is microscopic or macroscopic?
Microscopic.
Microscopic.
Microscopic study. Now, how to learn macroscopic here? If I consider one section, this is suppose section 1 1 and this is section 2 2. Here also required 1. So I can measure here velocity of that running water. So velocity of that running water is only of that molecule, or it is the result, or what we can say average of all the molecules flowing through that channel or the pipe.
Average.
Average of the all
Average
molecules.
of all the molecules.
Yeah, it is the average of all the molecules. So it means whatever study done with this method is come under the
Microscopic.
micro or macro.
Macro.
Yeah, it comes under the macroscopic. See, we all engineers are most of the time we are studying all the substances under macroscopic approach. Get it?
Yes.
Yes,
Yeah.
sir.
We engineers, and for application level we study, or we what we can say, well, yeah, we are studying under macroscopic approach only. Okay, very rarely we require that microscopic. So that microscopic point of view required for the scientist. For example, in last 2 years we have coronavirus. So if we have to study about this behavior of that coronavirus, so for that we need that microscopic study. Okay, and engineers are not involved in that. The scientist who is related to that, they involve in that and they find, okay, they study behavior of that coronavirus, how it behaves when he is single. Okay, then coronavirus taken out, and this study was done under the microscope because virus will not observe with the naked eyes. Am I right?
Yes, sir.
Okay, so henceforth we are learning all these things under the which approach?
Macro. Macroscopic.
Yeah, correct. Macroscopic approach. I think you understood that all microscopic and the macroscopic approach. Now we will move towards next slide. Working substance. Now working substance are mainly fluids. Fluids, it means working substance are the substance who are responsible to addition or subtraction of energy in the devices. So the working substances are mainly fluid. The fluid may be liquid or gas. Okay, liquid and gas. This is the classification of fluid. You can't say fluid means we consider. Okay, our psychology says that. Psychology, not psychology actually. We consider Fluid means liquid. Am I right?
Yes, sir.
And mostly we think about the water only. Fluid means liquid, and that is water. But fluid is divided in two parts, that is the liquid as well as gases. In liquid, water is the standard liquid. For comparison or to check behavior of other liquids, that is diesel, petrol, oil, there are a number of liquids. Okay. So to check that, we required some standards. For that, we refer water. And in gases, there are also a number of gases, and if we need to what we can say compare these gases with some standard, at that time we use air. Okay. Now, working substance are the liquid or it may be gases. It undergoes changes in its properties during energy transfer. ओके. जे लिक्विड आहेत, जे गॅसेस आहेत, हे काय आहेत? वर्किंग सबस्टन्सेस आहेत. फॉर एक्झाम्पल, इन सेंट्रीफ्युगल पंप, what is the working substance?
Water. Water.
Water. Water is the working substance in the centrifugal pump. Now, in compressor,
Air.
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 in compressor, air is the working substance. Now, in IC engine,
Oil.
IC engine, it means internal combustion engine, which is used in our vehicles,
Air.
motorcycles,
Petrol or diesel.
petrol or diesel, or it is the mixture of air and fuel. It may be diesel, it may be petrol. Okay, so this is the working substances. For example, in steam turbine, they given we have one example in front of us, that is steam in steam turbine. So to run the steam turbine, we need steam. Steam म्हणजे
Gas.
no, steam म्हणजे वाफ आहे, वाफ. ठीक आहे, पाण्याला हीट केल्यानंतर त्याच्या बॉइलिंग पॉईंटच्या नंतर इट इज द गॅसियस स्टेट ऑफ वॉटर. यू कॅन से इट इज द गॅसियस स्टेट ऑफ वॉटर. Okay, so these all are the working substance. The working substance can absorb the heat or they can reject the heat. Okay. For example, in a refrigerator, that is in a fridge, which is the working substance? Without working substance, it is not possible to add or extract energy. So in
Gas.
fridge,
Air.
fuel or gas. Okay.
Gas. Yes.
Okay, we consider gas. Actually, it is refrigerant. Okay, gas, and this is under liquid, or you can say gas, but these are the refrigerant. Okay, which attract or absorb energy inside the compartment where we want to cool that compartment. Okay, where we want temperature, lower temperature, from that working substance or refrigerant absorbs temperature or heat, and it will reject outside the compartment. Okay, so here refrigerants are the working substance. It does work or work is done on it. It means work can be done on it and it can work also. For example, in centrifugal pump, centrifugal pump work on the water. Am I right?
Yes, sir.
Centrifugal pump work on the water because due to the rotation of impeller, the cavity will create, and to fill that cavity, it will suck water or nearer water into the impeller. It means here the impeller work on the working substance. तुम्हाला समजतंय का सांगा मी बोलतोय ते?
Yes, sir.
Yes, sir.
ओके, मी एक्झाम्पल देतोय जे आपण अगोदर शिकलेलो आहोत त्यातलं एक्झाम्पल देतोय जेणेकरून समजण्यासाठी सोपं जाईल. ओके, and another working substance can also work on that other devices, that is steam can work in steam turbine, water can work on water turbines to rotate it. Okay, so it is compressible or expanded. Actually liquid cannot compress. Okay, gas can be compressed or expand. Okay, working substance झालं. Homogeneous and heterogeneous system. Now, what is the homogeneous and what is the heterogeneous system? I think you have learned it. And I hope you can teach me these points. So, who will tell me? Who will tell? Homogeneous.
होमोजियस म्हणजे इक्वल अमाऊंट मध्ये असते.
बर, थोडं स्पेसिफिक अजून.
होमोजिनियस मध्ये स्टेट सेम असतात. गॅस तर गॅस, सॉलिड तर सॉलिड.
सॉलिड तर सॉलिड, करेक्ट. अजून
हेट्रोजिनियस मध्ये गॅस प्लस सॉलिड, गॅस प्लस लिक्विड.
गॅस प्लस सॉलिड, गॅस प्लस लिक्विड. हेट्रोजिनियस मध्ये लिक्विड प्लस लिक्विड असू शकतं का?
No, sir.
Right.
Okay.
Solid plus liquid.
Yeah, it means suppose ice in water. Ice in water. हे कशाचं एक्झाम्पल असू शकतं?
हेट्रोजिनियस.
Heterogeneous.
Heterogeneous. Okay. It is the example of heterogeneous. Now, water, kerosene in water.
हेट्रोजिनियस.
Heterogeneous.
How it is heterogeneous?
Homogeneous.
नाही सर, होमोजिनियस.
See, we see here a system consisting of single phase is called a homogeneous system. Okay, it consists single phase and single chemical composition, we can say. Okay, we consider here only phase. If suppose there is single phase, then these substances are homogeneous substances. And if there is more than one phase, these substances are the heterogeneous substances. Now, if suppose I have here again we fill water. Most of the time we take example as a water because this one is the standard. Okay, and after that I add here salt. After that I add here salt. Salt will deposited at the bottom of that glass. Now you tell me, this one is the heterogeneous or homogeneous?
Heterogeneous.
चुकू द्या, चुकलं तरी काय नाही, माझं पण चुकत असते बऱ्याच वेळेला. मला पण माहित नाही होमोजिनियस काय आहे, हेट्रोजिनियस काय, आय डोंट नो.
सर इनिशियली ते हेटेरोजिनियस असणार आणि सॉल्ट त्याच्यात डिझॉल्व्ह झाल्यानंतर होमोजिनियस होणार.
या, बट नाउ दिस वन इज द स्ट्रक्चर इन फ्रंट ऑफ यू. नाउ टेल मी, दिस इज
Heterogeneous.
this one is the heterogeneous. Now after some time that salt get dissolved in the water. Then this salt get dissolved in the water. Now this structure is which type of structure?
Homogeneous.
Homogeneous structure.
Homogeneous.
Correct. This one is the homogeneous structure because it consists of single phase. that structure consists single phase, that structure consists of two phases. Now, if this is another glass and this one is the water again, okay, and in that, if I add honey here, honey माहित आहे मध,
Yes, sir.
Yes, sure.
if I put here, after that I put here kerosene. Now tell me,
Heterogeneous.
this one is the
Heterogeneous.
heterogeneous substance. So substance which is having single phase throughout, okay, at that time we can say this structure or this substance is homogeneous substance. When the phase of that substance are different, then we can say this structure or this total substance is heterogeneous substance. Get it?
Yes, sir.
तर केरोसिन आणि वॉटर असेल तर
कोणतं?
केरोसिन आणि वॉटर
हा. So think about that, whether kerosene dissolve in water or not.
No.
नाही सर
Not
फ्लोट
No,
dissolve.
sir.
No, if it is
Dissolve.
not dissolving in the water, so the mixture of kerosene and water is the heterogeneous mixture, or the that total mixture is heterogeneous structure. Okay.
येस सर
Now next one slide. So you understood homogeneous, heterogeneous?
Yes, sir.
Yes, sir.
Okay. You explained it very nicely. तुम्ही चांगल्या प्रकारे मला माहिती दिलीत. होमोजिनियस म्हणजे काय, हेट्रोजिनियस म्हणजे काय. Now pure substance. Now what is the pure substance?
प्युअर सबस्टन्सचे अमाऊंट चेंज नाही होत.
प्युअर सबस्टन्सची अमाऊंट चेंज होत नाही. ओके, म्हणजे मॅटर.
हा स्टेट
Yes,
बदलली
sir.
तरी अमाऊंट सेम राहते.
ओके, अजून कोणाच काय म्हणणं याच्यामध्ये?
केमिकल प्रॉपर्टीज पण सेम राहतात.
या, करेक्ट. So pure substances are the substances. The pure substances are very rare. Okay, pure substances are very rare because all where combination is there. The pure substances are substances which are homogeneous. It means they shows single phase, single chemical composition, and also it will not vary with the change in substance phase. Phase, it means, or state, solid, liquid and gaseous. Okay, so here we have water is the pure substance, so you can say here is the H2O. But here this H2 is the one element, O is the one element, and by combining that hydrogen and oxygen we get H2O, which is not changing when we change the state of substance. Okay, so for that water is the pure substance. Now for you, one homework, you have to search pure substances, and tomorrow you have to tell me different pure substances. Okay.
Okay, sir.
Yeah.
Okay, because they are very rare. Frankly, I also don't know the different pure substances, more pure substances. I know only water up to that. You check on the Google, you check on the books, you go, you have a lot of paths to search, but mostly Google is our guru now. Okay. Now next is, now we are moving towards the thermodynamic. Okay, that all part we have covered before that. This one is a common part. Okay, for all subject. It may be, it is required also in other studies also. Okay, now we are moving in the thermodynamics. Thermodynamics covers most of the things, that is the heat power, then fluid mechanics, fluid machineries. Okay, so it covers most of the area of mechanical engineering. Now system and control volume. So first we are going to see what is mean by system, what is mean by surrounding, and what is the boundary. So system, what is mean by system? Who will tell me? This one is very simple, and slide is also in front of you, so it help you to remember what you have studied in your 12th. Who will tell me what is mean by system? No one is there. माझा आवाज आहे?
Combination of body and surrounding.
Yes, yes. Once again.
Combination of a body and a surrounding.
Combination of a body and surrounding. No, I want only system. You are telling about the universe.
The part chosen
A part of
to
universe
study
under
the
thermodynamic investigation.
Yeah. For example, if I am teaching here to you, it means I am observing this computer. So for me, this is the system. For example, if suppose this is the water, and if I observe the behavior of that water, then this one is one system. Okay, so system, it means the area we choose for observation or area under the observation. Get it?
Yes.
Area under the observation, simple thing. Okay, it may be in gaseous state, it may be in liquid state, it may be in various states. Okay, if you are observing tube lights, okay, if you are observing tube lights, so tube lights, that system is the tube lights. Okay, I am giving example only. Okay, if you are observing vehicles, then that vehicle, that all boundary of that vehicle is the system, and other than vehicle, all remaining things are surrounding. Okay, get it about the system? Then tell me about the surroundings.
Area outside the system.
Area outside the system, all other area outside the system is surroundings. And what is the boundary?
Surface separating the system from the
System and
surrounding.
The boundary which separates the system and surroundings. For example, boundary may be what you can say, imaginary, or it is actually. So imaginary boundary or boundary may be fixed, or it may be movable. If suppose one vehicle moving on the road, okay, or it is stationary, and if suppose this is a new brand, and we are passing that vehicle, so we stop there and check all the parameters of that vehicle. Am I correct? एखादी गाडी नवीन ब्रँडची आलेली आहे आणि तुम्ही साईडहून जाताना तुम्हाला दिसली, आणि जी तुम्ही अगोदर पोस्टरमध्ये बघितलेली आहे आणि तुम्हाला वाटलं की हां in future I will buy this car. आणि ती तुमच्या समोर तिथं आली. Okay, so what you are doing? काय करता तुम्ही?
Check it.
You are checking, you are observing that vehicle. Okay, you are observing the shape of that vehicle, how internal facilities are provided. Okay, that all these things you are observing, and when you are observing the vehicle, so you have that boundary of that vehicle. Outside surface of that vehicle is the boundary, and other than the vehicle, all vehicles are moving here and there. If it is it is resting near to road, resting or stop. Okay, if it is stopped near the road, all vehicles are moving, but you are observing only one vehicle. Am I correct? If you are RT officer, then you observe all the vehicles. So it means that vehicle is your system, and all other vehicles, that roads and all these other things are surrounded by that vehicle is surrounding. Okay, and the surface of that vehicle is boundary. Am I correct?
Yes, sir.
If suppose this vehicle will move, and if you are observing, the boundary can move also. Okay, or that system, total system goes on moving. Am I correct? मी तुम्हाला एक्झाम्पल देऊन सांगतोय ऍप्लिकेशन लेवलचे. Only reading is not sufficient. A quantity of matter or region in space chosen for study. For example, now boundary is fixed or movable. If suppose here we have heat. Can you observe it? दिसते का सगळ्यांनी ही heat?
Yes, sir.
Yes, sir.
If we consider this heat as a system, if we consider that heat or fire, not heat actually, that fire as a system, then all other part is surrounding. Then all other part is surrounding. So whether that fire is constant or stationary, it
No,
will
sir.
move, it will move like that. Okay, so it means the boundary also move. Correct?
Yes, sir.
Now another thing, here this boundary is visible. In that case, in that vehicle, the boundary is visible. But here, is that boundary visible?
No. No, sir.
No,
Exactly.
it is not visible. It means boundary can be fixed, or it can be moved, it can be visible, or it may be
Imaginary.
invisible also. Okay, understood?
Yes, sir.
System, surroundings, and boundary. So tell me some your opinion about the boundary, or give some examples of fixed boundary. Okay, you don't have any examples. Yes?
Computer.
Computer, okay. This is the fixed boundary. Cup of tea. If tea is the system, the tea having fixed boundary. Yes, your mobile, fixed boundary. Glass of water.
Water
Water?
bottle.
Water bottle, correct.
Book.
Book, yeah, correct. Book is also having fixed boundary. Then now tell me some examples of movable boundary, moving boundary,
Box.
River
box.
water.
Yes.
River.
नाही ऐकू आलं मला. सायली.
रिव्हर सर.
विवर
रिव्हर.
नाही
आपण
कळालं मला.
एखादी रिव्हर ऑब्झर्व करत असेल तर त्यातलं पाणी
हा
हे
हा
movable असतं.
रिव्हर म्हणताय का तुम्ही? ओके रिव्हर. व्हेरी गुड. फ्री वॉटर म्हणजे फ्री वाहणारं जे वॉटर आहे त्याची बाउंड्री कशी आहे? मुवेबल आहे. व्हेरी नाईस एक्झाम्पल. व्हेरी गुड. इट मॅचेस ॲज इट इज. Okay, so you search these also, movable boundaries and fixed boundaries. You place check whether we have more examples. And now we will move towards next. So here also given that moving boundary, here is also moving boundary. So this example is like that. This is the piston or some plate which is kept on that. So when we add energy in the form of heat, at that time, due to that molecular vibration or that energy we have added here, that boundary can move in the upward direction. Am I correct?
Yes, sir.
बाउंड्री मी जर तापवत गेलो, हे जे काय गॅस आहे हा जर तापवत गेलो मी, तर त्याच्यावर असणारी जी प्लेट आहे ती वरच्या डायरेक्शनने मूव्ह होईल का?
Yes, sir.
Yes, sir.
सो इट मीन्स ती बाउंड्री काय झाली? मूव्ह झाली. आता थोड्या वेळानंतर मी फायर काढून घेतो त्याच्यामध्ये मी एनर्जी ॲड केली. ओके, त्याच्यासाठी मी बाहेरून त्याच्यासाठी आर्टिफिशियल फायर प्रोव्हाइड केली. सो हिअर आय हॅव ॲडेड एनर्जी. So that energy works here and energy pushes or apply force on that plate in upward direction. Okay, it is not mean that it is apply force in only upward direction. That energy apply force in all direction. Most of the time our mind thought that, our brain thought the pressure is applied only in one direction, but pressure applies in every or all direction. But this plate will move because it is movable. हे फक्त मूव्ह होऊ शकतंय म्हणून हे मुवेबल आहे. त्या बाजूला मूव्ह होतंय का? ही बाउंड्री फिक्स आहे या बाजूला म्हणून इकडे मूव्ह होत नाही. इट इज नॉट मीन that energy not applying force in this direction. Okay, so here due to that force, that movable boundary move in upward direction. After some time, if we remove this fire, then what will happen?
Original state line are gone.
So that plate tries to come at its previous state. Why? Because that energy rejected by that system, if suppose this is the system, energy rejected by that system towards the surrounding or environment. Why it is happening? Why it is happening?
Equilibrium condition.
Yeah, correct. To achieve equilibrium condition, temperature or energy transfer from the system to the surrounding. Because here or we can say potential difference also, or the temperature difference. Temperature, this is the property of that system. When temperature is always flowing from higher temperature towards the lower temperature. So to achieve the thermal equilibrium, okay, to achieve the thermal equilibrium, the temperature will release in the environment, and as the temperature releases, it means it is the form of energy. So due to that, this plate will move in the downward direction and it will take its original position or previous position. Okay. So do you understood these things? Today we learn homogeneous, heterogeneous, pure substance, system, surroundings, and boundary. Is anyone having any doubt in that? No. If nobody is talking, it means I consider there is no doubt. Okay, with this, we will stop here. In next lecture, we will see the types of systems and some examples on that. Okay?
ओके सर.
सर सिलेबस काय आहे तिला?
ISC ला तुम्हाला 2 चॅप्टर असतील. ओके, पहिला पंप कॉम्प्रेसर टर्बाइन आणि दुसरा
मशीन टूल.
मशीन टूल आणि जॉईनिंग प्रोसेस. तुमच्याकडे मटेरियल सगळं अवेलेबल आहे, त्याच्यामुळे
MCQ टाइपच असणार ना सर?
हा MCQ टाइपच. ऑल
25 मार्क्स ना?
काय झालं?
25 मार्क्स.
हा 30 मार्क्स, 30 मार्क्स. 30 मार्क्सची बघा, 30 मार्क्सची ISC असणार आहे, ज्याच्यामध्ये 15 क्वेश्चन हे सिव्हिल इंजिनिअरिंगचे असतील आणि राहिलेले 15 हे मेकॅनिकलचे असतील. ठीक आहे?
ओके. येस.
ओके सर. सर सिस्टीम सांग का?
काय झालं? सिस्टम.
सिस्टीम आणि सराउंडिंग.
सिस्टम म्हणजे एरिया विच इज अंडर ऑब्झर्वेशन, म्हणजे जो काही एरिया आपण ऑब्झर्वेशनमध्ये पकडतोय. ओके, तर तो एरिया. आता मी सध्या तुमच्या समोर बसलोय, पण इथं PCच्या समोर बसलोय. आय एम ऑब्झर्विंग दॅट स्लाइड्स इन फ्रंट ऑफ मी, that your numbers are there, your names are here on the left side, that I am observing here. Okay, so this is system for me now. Other than this, there are benches, blackboard, there are so many things are surrounding to here. So these all things which are not I am observing, these all things are surrounding. Okay.
ओके सर.
Okay. So thank you all of you. We will stop here and we will meet in the next lecture.
सर प्रेझेंटी?
प्रेझेंट तुमची सरांनी घेतली ना? प्रेझेंट राहील. तुम्ही एक काम करा, यू पुट इन टू द चॅट बॉक्स. I will tally this with first lecture. So all of you put your attendance into the chat box.
सर ह्या चॅप्टरच्या नोट्स.
हा, याच्या नोट्स ठेवतो मी. 1-2 लिंक तयार होऊ द्या, तिथं मग ठेवतो.
ओके
सर
चॅप्टरच्या नोट्स पण देतो, MCQ पण ठेवतो तिथं.
ओके
सर ते डायग्राम 24 डायग्राम काढायचे का सेकंड ह्याच्यामध्ये सगळ्या?
हा, सगळ्या काढायच्या डायग्राम.
एक पार्ट, त्या पार्ट मधले पण पार्ट दिलेत, मग ते पण काढायचे का?
पार्ट मधले पार्ट कोणते म्हणता तुम्ही?
म्हणजे
नाही
सब
सर,
डायग्राम.
हा एकच काढायचं ना सर.
हे बघा, लेथ मशीन काढायची,
ड्रिलिंग.
ड्रिलिंग मशीन काढायची, त्याच्या खाली ड्रिलिंगचे जे ऑपरेशन्स आहेत त्या ऑपरेशनची डायग्राम काढायची.
ड्रिलिंग मशीनचीच काढली सर.
होय का? मग ऑपरेशनची पण काढा की त्याच्या खाली, किंवा MCQ झाले त्याच्या खाली काढा.
डायग्राम सर लय कन्फ्युज झाले, काय नाही कोणचे
सबमिट
काढायचे.
केलं.
डायग्रामचं काय झालं?
कन्फ्युज आहे सर, काय समजतच नाही कोणत्या काढायच्या नेमक्या.
तुमच्याकडे हे बघा, मी सांगतो तुम्हाला, तेवढं लक्ष द्या. लेथ मशीनची काढायची, ड्रिलिंग मशीनची काढायची.
सबमिट केलं.
सबमिट केलं?
मी पण.
हा सर.
8 डायग्राम झाले.
बरं ठीक आहे, ज्यांचं राहिले त्यांनी सांगतो आता. मग ऑपरेशनच्या काढलेत का नाही तुम्ही?
नाही काढलं
नाही
सर.
सर,
त्या बुक मध्ये काढलं होतं तेवढंच.
बरं ठीक आहे, ऑपरेशनच्या राहू द्या, मग ऑपरेशनच्या काढू नका.
तर कोणच्या काढायचं सांगा ना एकदा.
हे बघा, लेथ मशीन, ड्रिलिंग मशीन, त्याच्यानंतर आर्क वेल्डिंग, गॅस वेल्डिंग, त्याच्यानंतर कुठली काढली?
स्पॉट वेल्डिंग.
स्पॉट वेल्डिंग, सोल्डरिंग, आणि प्रेझिंग.
Freezing.
1
हा,
2
sir.
3 4 5 6 7 आणि 8 झाल्या बरोबर.
काढलेत sir.
ठीक आहे, ओके. थांबूया आपण इथे.